All right, in the backward pass, what we're doing calculations starting from the ending nodes and moving backward until we reach the starting node. And remember that the backward pass is done after we have already found the early start and early finish of all the activities. Okay, so I'm going to record the late finish and the late start again in the first and the third parts of the node. Now the procedure is like that. To start, how can I start? Since I don't want to delay my project, so I set the late finish of the last node only, okay? The late finish to be equal to its earliest finish, meaning that I'm telling I cannot give you a flexibility. You are the ending node. You were found to be finished at its earliest at that time. You have to finish at your latest at that time. That's it. Now, within a node, moving backward, it will be the opposite of the forward pass. So we have the latest finish and we have the duration, and now we find the latest start. How? Which is equal to the latest finish minus the duration. Simple. Remember one thing. Always remember when you're doing the backward pass, don't forget that the project happens in a forward way, right? So from starting to the ending, here we're only doing the calculations backwards. All right. Now, if activity A has only one succeeding node, this is easy, then the latest finish of activity A will be equal to the latest start of activity B. Let me show you that. So remember, here we are doing a backward pass, which means what? Which means that we already have found the latest finish of B and the latest start of B. Let's say this is 7. So we are saying B can start at its latest by week 7. So this will allow me to find the latest finish of A, which is what? It will be also 7, right? Since I'm allowing B to start at its latest by 7, that means I cannot allow A to finish at its latest more than 7. It has to be 7. Now, things can be a little bit, or we need more attention when an activity has two succeeding nodes, B and C. Look at this, like that. So A is an immediate predecessor for B and C. So again, we're going backward. Let's say we found this to be 9, okay, and this one to be 11. So what can be the latest finish of A, right? C has a latest start of 9 and B has a latest start of 11. When do you think will be the latest finish? How can we allow A to finish? When can we allow A to finish at its latest? What do you think? Can we do that at 11? If we do that at 11, that means C cannot start. So I cannot do this. This is wrong. That means the latest finish of A has to be 9 so that it allows C to start. Okay? And that's what I wrote here, that the latest finish of A will be the smallest of all its succeeding nodes, right? Because it needs to allow the first one to start. All right, I hope that was clear. We're going to do also an example to implement this procedure. It will become even clearer. All right, so backward pass that comes after the forward pass is done. That's why you can see that the early start and the early finish of all the activities are already determined, and now we're starting backward. So we're starting from activity 7. All right, so we're starting here. For activity 7, we set, because it's the ending node, we don't want to delay the project, so we set its latest finish equal to the earliest finish, so we set it equal to 20, right? Then the latest start will be what? 20 minus 1, it will be 19. Now we go to activity 6. Activity 6 is immediate predecessor for 7. And 7 has a latest start of 19, which means I can allow 6 to finish at its latest by 19. You see the logic here? Very important. Then the latest start of 6 will be 19 minus 3, so that's 16. For activity 5, also same scenario. It has only one succeeding node. So because 7 has a latest start of 19, then I can allow activity 5 to finish at its latest by 19. I cannot allow it 20, for example, because then 7 will be delayed, but 19, right? So you can see now the amount of flexibility I'm having. It has a latest finish of earliest finish of 13, but a latest finish of 19, so 6 weeks difference. We're going to talk about that 6 weeks different later. Then the latest start, 19 minus 9, 10. Then activity 4, also 19 here, minus 11, that's 8. Activity 3, it's 16, minus 6, that's 10. Activity 2, 10, minus 4, 6. Activity 1, what do you think? Before, why don't you pause the video and think about it? What do you think would be the latest finish for activity 1? Yes, activity 1, okay, is an immediate predecessor for 2 activities, 3 and 4, and 3 has a latest start of 10, 4 has a latest start of 8. So which means I cannot allow activity 1 to be delayed to be finished after week 8. Why? Because otherwise 4 will be delayed. So that will set my latest finish for activity 1 to be 8. Here we go. Then 8 minus 8 is 0. Then the starting node, which is virtual, by the way, it has 2 succeeding nodes, node 1 and node 2. So the latest finish here will be the earliest of these 2, so which is 0 in this case. So here we go, and 0 minus 0 is 0. And it's not by coincidence that we are seeing zeros all over the node here. Why? Because that was a virtual node. So you expect that, right? In a virtual node, all the values are 0. If you find any value which is not 0 here, make sure that you have done some mistake somewhere, okay? And you need to revise your calculations. All right, so I hope that was clear. We're going to proceed further using this P&D. We're going to learn more from these early start, early finish, late start, and late finish. All right, now we're going to benefit from the calculation that we have done in the forward and backward pass in order to find a very important metric for every activity called the slack time. What the slack time? Very important concept again. It's the amount of time that an activity can be delayed without delaying the whole project. This is very important because in real life, project managers need some room for mistakes, or to adjust some activities, or to adjust some resources. Very important, and that costs time. Now, if they know that some activities can be delayed without delaying the entire project, they would be very, very happy. So it's very important to identify the slack time of every activity in all the projects. Okay, so how do we do it? It's very easy, as you could have started having the feeling of it when we were doing the backward pass. The slack time is the difference between the latest start and the earliest start, and would be exactly the same as the difference between the latest finish and the earliest finish. Okay, you have exactly the same value here. So when you find an activity that it has a 0 slack, you say that this activity is critical, which means that once you finish the backward pass and you see all the slacks on all your activities, you are able to identify the critical path by identifying a path that has activities that all have 0 slack. then this will be your method to recognize the critical path. Now, something that we will be discussing more in the next slide when we do the example, we'll talk about the shared slack or total slack. When 2 or 3 or 4 activities in the same path have slacks, these slacks are not cumulative, meaning that these activities share some of the slack. I'm going to talk about it in the next slide. Okay, but please always remember a shared slack or a total slack among activities in the same path. All right, so let's find the slack time for all these activities. Again, remember, we have done already the forward pass, the backward pass, which allowed us to find all these 4 values for each activity in the project. So let me present for you one done for you so that you can proceed before I show you how to do the slack time for the others. For activity 6, remember we said the slack time, you find it by finding the difference between the early start and the late start, or early finish and the late finish. So we could see that for activity 6, this is 19, 17, so the slack is 2, which should be exactly the difference here, right? If this difference is other than the difference here, that means there's something wrong. Okay, there was something wrong in your calculation. All right, let's find the slack for the others. So I will put the slack time underneath the node for each activity. For activity 7, it's 0, right? Because you remember this is how we started the backward pass in the first place, by setting this to be equal to that. So certainly the slack is 0 here. For activity 5, okay, it's 6, which is 19 minus 13, 19 minus 13, or 10 minus 4 should give you the same result. For activity 4, it's 0, because the early start and late start are the same, and this early finish and late finish is the same. Activity 3, it's 2. Activity 2, that's 6. Activity 1, it's 0, and the virtual node, it's 0. So what do you notice here? You can see that there is a path that starts the starting node and the ending node and consists of all activities with 0 slack. So here we go, we found the critical path. Okay, but here be careful. If you just wanted to find the critical path given a certain P&D, don't do that. Don't find the early start, early finish, late start, late finish, and the slack time, because it's time consuming. If you simply just wanted to find the critical path, all what you have to do, list all the paths, find the duration of each path, and the longest path is your critical path. So don't do that exercise until you are explicitly told to find ES, EF, LS, LF, or the slack time of all the activities. Okay, so I hope that was clear for you.